Electrical items. There are three inspectable items: electrical conductor outlet switch, electrical GFI AFCI, electrical service panel. Electrical items are another category of defects that have been significantly changed from UPCS to NSPIRE. Under UPCS, we had 11 different defects that overlapped in sometimes confusing ways and that could be cited under building systems, common areas, and units. Two of these then, the health and safety defects, could also be cited under site and building exterior. Starting with those electrical hazards under health and safety, they were exposed wires, open panels, and water leaks on or near electrical equipment. Those could be cited in all 5 inspectable areas, and they were 2 of the highest scoring defects in the entire UPCS protocol. Electrical system defects could be cited under building systems, common areas, and/or units. These included blocked access to a breaker panel, burnt breakers, evidence of leaks and corrosion, frayed wiring, GFI inoperable, missing breakers or fuses, and missing covers. Outlets and switches were a separate inspectable item, and they could be cited for missing outlet or switch and/or for missing broken outlet switch cover plates. 4 of these old standard defects represented exposed circuitry shock hazards. The 2 electrical system defects, missing breakers and missing covers, the outlet switch defect, missing cover plate, and the health and safety item, exposed wires, open panels. Although all of these represented life-threatening shock hazards, they scored very differently. If we were inspecting a 100-unit property that had only one building, for example, a missing outlet cover in a unit low on the wall where maybe a baby could reach it, it was only worth about 0.2 of a point. A missing knockout in a timer box inside a locked mechanical room that was off limits to the residents entirely could be worth as much as 10 points. Going back to the missing outlet cover, down low on the wall within reach of a baby, it was worth 0.2 of a point. A narrow 1/4 inch gap between the breaker and the dead front cover inside a closed breaker panel 5 feet off the floor would be cited as exposed wires, and it was worth about 1.6 points. But if instead the entire dead front cover was missing from the panel entirely, that would be cited as missing cover, and it was somehow worth only about 1.1 points, less than the small gap. With the design of NSPIRE, REAC has unified all of the apparent shock hazards into one deficiency under electrical conductor outlet switch. Deficiency 4 is called exposed electrical conductor. But let's look at the entire electrical conductor outlet switch item with its deficiencies in order. We first find some definitions. A conductor is an object or a type of material that carries electrical current. An outlet or switch, installations that connect to an electric supply and allow the user to safely access power to energize electrical devices. Common components include receptacle, outlet, faceplate, wire, electrical conductor, bus bar, terminal, wire connection, cables, junction box, including a switch box, a light fixture box, a smoke detector box, a receptacle box, wire nuts. For more information, low voltage wiring, for example, telephone, doorbell, thermostat wiring, is excluded from this standard. Deficiency 1. Outlet or switch is damaged. Deficiency. Any portion of a visually accessible, that is, can be reasonably accessed and observed, outlet or switch is damaged, i.e. visibly defective or has a problem that impacts its functionality, such that it may not safely carry or control electrical current at the outlet or switch. For more information, an electrical conductor that's not enclosed or properly insulated should be evaluated under deficiency 4 of this standard. This seems to suggest that all shock hazards still go under deficiency 4 instead of here. An outlet that is inoperable but does not have visible damage should be evaluated under deficiency 3 of this standard. A switch that's inoperable but does not have visible damage and corresponds to a hardwired fixture or appliance should be evaluated under the respective items standard. Examples include but are not limited to lighting on the interior, lighting on the exterior, lighting auxiliary, electrical conductor like missing light bulb or a damaged cover plate, sharp edges on a broken light bulb, water heater standard, cooking appliance, garage door, kitchen ventilation. So anything that can't be operated should go under the standard for that item instead of under switches and outlets. Deficiency 2. Testing indicates that a 3-pronged outlet is not properly wired or grounded. Deficiency. Testing of a 3-pronged outlet that is reasonably accessible, you can reach it without moving obstructions, dismantling, destructive measures, or actions that may pose a risk to persons or property, indicates that it's not properly wired or grounded. More information, a 3-prong ungrounded outlet that is GFI protected or GFCI protected is not considered a deficiency. An outlet that is not energized and does not have visible damage should be evaluated under deficiency 3 of this standard. Deficiency 3, outlet does not have visible damage and testing indicates it is not energized. Deficiency, an outlet that's reasonably accessible, that is, it can be reached without moving obstructions, dismantling anything, etc., does not have visible damage, and testing indicates that it is energized. And we'll talk about what type of tester an inspector should be using when we get to the GFCI standard. It is now understood that inspectors will carry and will use an outlet tester. Deficiency 4, and here finally is our shock hazard defect, exposed electrical conductor. Deficiency, an electrical conductor is not enclosed or properly insulated, e.g., it's damaged or it's missing sheathing that exposes the insulated wiring or conductor. There's an open port, a missing knockout, a missing outlet or switch cover, or a missing breaker or fuse. An opening or gap is present and measures greater than 1/2 inch. So we've gone from a 1/4 inch gap under UPCS to now requiring a 1/2 inch gap before we write a shock hazard. For more information, if improper material is used to insulate a conductor or fill an unintentional gap, then it should be evaluated under this deficiency. Example conductors to be evaluated under this deficiency include, but are not limited to, knockouts. A knockout's not really a conductor, but a missing knockout may expose a conductor. Device cover plates that are missing, i.e. there's evidence of prior installation, but it's now not present or incomplete. Device cover plates that are damaged, i.e. they're visibly defective, or there's something that impacts their functionality. Problems at light fixtures, visible nuts on electrical conductors, wiring that is insulated but not protected by sheathing or conduit, hardwired smoke detector with an exposed conductor, wall-mounted light fixture with a damaged or missing cover. Example conductors that should not be evaluated under this deficiency include, but are not limited to, low voltage wiring, in other words, telephone, doorbell, or thermostat wiring, a device designed by the manufacturer to intentionally have a gap or space to support ventilation, light fixture wiring that is exposed by design, ceiling-mounted light fixture with a damaged or missing cover, and other than electrical service panels, an inspector should not open any electrical enclosures to evaluate for this deficiency. So, under UPCS, an inspector was not to open secured electrical boxes, but was to open any unsecured electrical boxes. According to this standard, an inspector should no longer open any electrical enclosure other than service panels. If a light bulb is missing from a fixture, then it should be evaluated under lighting interior or lighting exterior standards, respectively. Deficiency 5, water is in contact with an electrical conductor. Deficiency, water is currently in contact with an electrical conductor. So this is not for situations where water seems to have been infiltrating at one time but is no longer there. This says currently in contact with an electrical conductor. That brings up our next inspectable item, electrical, GFCI, AFCI. And I'm going to use GFI and GFCI interchangeably. GFCI, of course, means a ground fault circuit interrupter. We need GFIs in environments where the presence of water might aggravate or intensify a shock hazard. We typically find GFCIs in kitchens, bathrooms, and laundry areas, wherever we might find a sink, bathtub, toilet, hose bib, etc., including sump pump pits and outlets outdoors. AFI or AFCI means arc fault circuit interrupter, and AFCI eliminates or significantly reduces sparking at an outlet when a plug is inserted or removed. This is done to prevent fires. AFCIs generally protect outlets in living areas where a spark is more likely to cause a fire, let's say at a curtain or some other decorations. Deficiency 1, a GFCI outlet or breaker is not visibly damaged, but the test button or reset button is inoperable. Deficiency, GFI outlet or GFCI breaker does not have visible damage, and the test or reset button is inoperable. The overall system or component thereof is not meeting its function or purpose. More information, some outlets are wired in series and may have one GFCI that provides protection to the entire series. This note reminds us that an outlet may be protected by another outlet upstream or by a breaker upstream, even though it does not have test buttons on the outlet itself. A GFI outlet or GFCI breaker test or reset button that is missing and results in an exposed conductor should be evaluated under electrical conductor outlet and switch standard. An acceptable industry standard tester may be used in place of the test and reset buttons if it meets all requirements of Underwriters Lab Standard 1436 for outlet circuit testers. Deficiency 2, AFCI outlet or AFCI breaker is not visibly damaged, and the test button or reset button is inoperable. Deficiency, the outlet or breaker does not have visible damage, and the test or reset button is inoperable, i.e., the overall system or component thereof is not meeting its function or purpose. More information, an AFCI outlet or AFCI breaker test or reset button that is missing and results in an exposed conductor should be evaluated under the electrical conductor outlet and switch standard. Deficiency 3, an unprotected outlet is present within 6 feet of a water source. This comes under affirmative habitability requirements. Deficiency, an outlet is present within 6 feet of a water source, sink, bathtub, shower, water faucet, toilet, that is located in the same room, and the outlet is not GFCI protected. More information. Outlet protection methods include GFCI outlet, GFCI breaker, or an outlet wired in series that's protected by another GFCI outlet. An outlet dedicated to a major appliance like a water heater, HVAC device, refrigerator, washing machine, dishwasher, garbage disposal, or other appliance that is wall-mounted or installed within a cabinet. Now that's the outlet, not the appliance, but the outlet is wall-mounted or installed within a cabinet should not be evaluated under this standard, regardless of its distance from the water source. An outlet located below a countertop and within an enclosed cabinet should not be evaluated under this standard, regardless of its distance from the water source. An electrical conductor that is not enclosed or properly insulated should be evaluated under electrical conductor outlet and switch standard. And that brings us to our last inspectable item under electrical service panel. Electrical service panel. It is an enclosure, a cabinet, or a box, or a panel board containing overcurrent protection devices, fuses or breakers, for the control of light, heat, appliances, and power circuits. Common components include an enclosure box, an internal cover, external cover or door if so designed, dead front cover, breaker, or fuse. Deficiency 1. An electrical service panel is not reasonably accessible. This replaces our old blocked access deficiency. Deficiency: electric service panel is not reasonably accessible, i.e., it cannot be reached and opened without moving obstructions, dismantling, destructive measures, or other actions that may pose a risk to persons or property. More information. If the electric panel is servicing the unit is located behind a locked door and the resident or POA cannot unlock the door at the time of inspection, then it is not reasonably accessible as defined by this standard. If the resident or POA cannot unlock the electric service panel door at the time of inspection, then it is not reasonably accessible as defined by this standard. So that's 1, if you can't unlock the door to the room where the panel is located, or when you can't unlock the panel itself if the cover to the panel is locked. Deficiency 2, an overcurrent protection device is damaged. Deficiency: the overcurrent protection device, i.e. breaker or fuse, is damaged, i.e. it's visibly defective or something impacts its function, such that it may not interrupt the circuit during an overcurrent condition. For more information, electrical components and connections located behind the panel cover, i.e. the dead front cover, are not evaluated under this standard. An electrical conductor that's not enclosed or properly insulated should be evaluated under electrical conductor outlet and switch standard. And deficiency 3, the overcurrent protection device is contaminated. Deficiency: the overcurrent protection device, the fuse or breaker, is contaminated. There's water, rust, or corrosion. For more information, electrical components and connections behind the panel cover, the dead front cover, are not evaluated under this standard. An electrical conductor that's not enclosed or properly insulated should be evaluated under the electrical conductor outlet and switch standard. So that's the rundown on our electrical inspectable items. If you found this video helpful, we'd appreciate it if you would like the video. If you haven't already subscribed, please do so to make sure you get any special emails or additional information that we might send out. This is Michael Gant for the Inspection Group and React Guru. Thanks again.